Hello everyone, welcome to Bizotech. In this video, we will be learning about an interesting quantitative aptitude topic, alligations and mixtures. Before we go forward and learn about concepts, let's understand the basic idea of alligations and mixtures. The first thing, mixtures. Mixture is a substance made by mixing other substances together. And there are two kinds which are very common. And the first kind is called as simple mixtures. When two or more different ingredients mix it together, a simple mixture is formed. So that can be as simple as mixing water with milk or mixing rice of two different prices. That can also be a mixture, a simple mixture. And then there comes the compound mixtures. When two or more different mixtures are mixed together. So here mixtures itself will be mixed together forming a compound mixture. An example, two alloys containing more than one types are mixed in different proportion. Maybe like K2SO4 mixed with NaCl forming some potassium nitrate. So all these kind of different alloys mixed together, they form mixtures which are compound mixtures. And now let's understand about alligation. It's a rule that enables us to find the ratio in which two or more ingredients at a given price must be mixed to produce a mixture of the desired price. So to make it very simple, it's nothing but alligation is a method which will help us to decode those compound mixtures. As simple as that. So you have to have this in your mind. So in order to decode compound mixture, there is a method which is called as alligation. And let's see what is that method is all about. There are two methods. In that, the first one is if two ingredients are mixed in a ratio and the cost price of the unit quantity of the mixture called the mean price is given by. So it has a formula in order to find out the mean price, which says the ratio of quantity of cheaper to quantity of dearer is equal to the ratio of difference of CP of the dearer to mean price to the difference of mean price minus CP of cheaper. So this is kind of little complex in order to remember and carry this formula. To make this even more easier, so it has been derived in a simple terms, and that has been given in this slide. Here, in order to derive that formula, D will be acting as the cost of dearer ingredient, and M is a mean price, and C is the cost of cheaper ingredient. Now it's very easy. D for dearer, C for cheaper, and M for mean price. So which that we have the formula to find out the alligation. CP of cheaper to CP of dearer. CP is the cost price, mean price, and DM minus M minus C. So you can now remember even more better. D minus M divided by M minus C. DM MC. If you remember that, then you can solve alligations in a very, I would say, perfect and a well-defined manner. And this you can verify when we started dealing with problems. So the formula will be dm divided by d minus m divided by m minus c, which is equal to cheaper quantity divided by dearer quantity. And now we have the last thing, method 2. Repeated dilution is used to calculate pure quantity left after n number of processes of repeated replacement is done on the pure quantity. So here, what does this method 2 mean is, so when there is a mixture and if in that mixture something is being taken out and being poured into some pure quantity, so that is where the repeated dilution happens. Example, suppose a container contains X units of liquid from which Y units are taken out and replaced by water, so to make it diluted. So in that case you will find out the number of dilutions being made as, after n operations, quantity of pure X will be X into 1 minus Y by X whole power n. And here the mean price will be the cost price of a unit quantity of the mixture is called the mean price. The cost price of a unit quantity of the mixture. So now all that you need to remember is, so how to deal with alligations in order to find a different varieties, mix it together. So that would do. So with this concept, in our next video, we will be solving a couple of problems in different kinds. Thank you so much for watching.